Hello everyone, welcome back to my channel Technish, where we are currently doing an intermediate series on Kotlin and we will be going step by step. In today's video, we are diving into Kotlin's most powerful features, collections and their operations. We will cover map, filter, reduce, flat map, immutability and laziness. Whether you are building an app or crunching data, this concepts will supercharge your Kotlin skills. So let's get started. Okay, so first we will check the collections and immutability. So Kotlin collections are divided into immutable and mutable classes. Okay, the immutable collections are like a list of, set of, cannot be modified after creations. Okay, and mutable collections such as mutable list of or mutable set of allow you to add or remove or update elements. Okay, so let's go to the editor and let's see. Okay, so let's do on a by default, that is immutable one. So in the immutable one, by default, what you get is, let's do an immutable list. Okay, and you do a list of 1, 2, and 3. So whenever you create this list will be based off immutable. So when I do println, you will be able to print it. So whenever you are initializing the list with list of, it will give you the immutability. So if you try to add or append something, as you can see, there is no method for it because it is, you can't add the items here. Okay. So let's see what it prints. It will print 1, 2, 3. Okay. Now, if you are going for similar things like set off, it will give you the immutability as well. Okay. If you are looking for mutable, then you will see what mutable list. Okay, and you have to do is mutable list of, that is 1, 2, 3. Okay, now this list can be modified. Okay, suppose if you do that mutable list dot add, so it's just like the string buffer or string builder, that whenever in Java you would have seen that whenever you are declaring a string, so that string becomes immutable. And whenever you are trying to add those, I mean, whenever you are trying to, edit those strings, in order to do that, you had to do string buffer or string builder, right? That would have given you an append method that would append the characters or the character sequences of strings that you have. But here, if you want to do that, you need to declare it with mutable list or mutable set. And suppose we add 4. Okay, you have a method to add. So if you go here, you can check this interface. We have mutable list is having a method called add, remove, add all and all. You can check the documentation here. And if I want to print it, as you will be able to see that the mutable list got changed with the append of 4. Okay, as you can see, 1, 2, 3, 4 has been printed. But always remember, whenever it is possible, stick to immutable collections for safer and predictable code. Okay, so you don't get any surprises. That's what we do for the final classes, right? So whenever we do final classes, there would be no data altercation and the other stuff. That's why the immutability does not, it will give you, predictable code. Okay. Next, we are going to discuss is, okay. Next, we are going to discuss map and filter. Okay. So what is map and filter? These operations allow basically to transform and filter the collections elegantly. Okay. Suppose I am taking val numbers. Okay. And I take a list of 1, 2, 3, 4, 5. Okay. Now I will try to show you the transformation using map. Okay. Now suppose I want to do the squares. It is just like the way you do that in streams. Okay. Suppose I want to do squares. Okay. and I do numbers dot map, and I will do is it. So instead of this in Kotlin, we do it. Okay. So it's the same thing. This is this in the it is this in Java. Okay. So if you do that and you try to print it, you see that it has been transformed with squares because we have printed the same thing twice. Okay. And suppose you want to filter some of it, right? We will try to do filter. In those cases, what I can do is, suppose I want to check and odd and even. In those cases, suppose I take an even. I mean, only the even numbers I can filter. I will filter out. In those cases, I will do is numbers dot filter, and I will do is instead of this, I will print it, and I will do is the modulo operator and divided by 2, and I'll do 0. In those cases, I will do even. So it will filter out all the even ones. It will check that the remainder is 0 or not. It will check all the even ones. Okay. See how simple that is. With just one line, you can transform your data. Okay. So next, we are moving towards reduce. Okay. So reduce is perfect whenever you need to combine all the elements in a collection into a single value, like a sum or a product. Okay. So if I do this, if I want to take that, you have the numbers. Okay. Now I want to take the sum of it. Suppose I do sums, and you want to do is with reduced. Okay. With reduce, what you can do is suppose I take an intermediate variable, that is suppose accumulated, and the accumulator will define by, I mean, it will be initialized or the storing the numbers via num, that is the intermediate variable here. And what I'll do is accumulator plus num. Okay. So these are the two intermediate variables that I have declared here inside the block of code, and here you go, you get all the sums here, and you will see all the sums here. Okay. It has been reduced with the sums of individual elements. That's what we are discussing. That is the, instead of going via the result equals to result plus I, where the I has been declared in the for loop initializer, we can do a simple transformation here with the sum itself. Okay. So this is what reduce. So here is, as it is clear that the accumulator that keeps running in total, and the operation is pretty concise and useful. Okay. Now let's move to flat map. Okay. So it's a very interesting thing. Okay. So if you have nested list, okay, in that nested lists, what you need is, suppose you want to flatten the list with a single one. Okay. Suppose you have a nested list. We are discussing flat map here. So flat map is, I am declaring a nested list. Okay. And I will do is declare a list of, and inside that list of, I will declare one, two. Okay. Suppose I do, okay, I will do another list. So it's a list of list. Okay. Three, four. Okay. And I will take five as well. Okay. So whenever we want to, check, suppose you want to flatten it, because this is list of list, right? And you want to flatten the entire list and transform it. In those cases, what I'll do is, I'll do flat map. Suppose I will be creating flat mapped. Okay. And in the nested list, I will operate flat map. Okay. Inside the flat map, I will take the individual list, and after that what I'll do is I'll create a map inside it, and I will do an intermediate variable, that is num, and I will do is Suppose I will multiply it by 2. Okay, so now it has been flattened individual elements. It is not in the same hierarchy anymore, it is the same flattened hierarchy. Okay, now you can check that it has been flat mapped with the transformations. As you can see, it has been transformed. So flat map first flattens the entire collections, that is this one, and after that it applies the transformation, that is, so this is a basically two-in-one powerhouse. Okay, now let's move to our next thing, that is the laziness with sequences. Okay, and let's define that. Okay, what is the laziness? Okay, so Kotlin collections are eager. I mean, meaning they process everything at once. For large data sets, this can be quite inefficient. Instead, you can use the sequences for lazy evaluation. Okay, so how it does? Let's see that. Okay, so we will do is laziness. Now let's take well numbers, and I'll take a range function here. Okay, and I will take it as a sequence. Okay, now after that what I'll do is, instead of this, let's, okay, it is already there, no, numbers one, so yeah, and I will do what, I will take it as a filtered one. Let's filter it, numbers one, and after that I will do is filter. Okay, and after that I will do is it dot, sorry, first I will do is I'll take the remainder. Okay, equals to 0, and after that I will transform it into a map, and I will do is it into it. Okay, and after that I will take 5. Okay, so let's run it by printing it. Okay, so with the sequences, operations are performed as only needed, saving the memory and processing power. As you can see, this is, if you take it as a sequence, you can perform a sequence, like the way you want to process it. Okay, for larger data sets, it is pretty easy. Okay, it is pretty easy rather than writing individual functions. You can do that as a sequence. Okay, so we have covered most of the cases, like the operations, transformations, map, filter, reduce, flat map, immutability, and laziness. So that's it for today's tutorial on Kotlin collections. We explored all the relevant topics here. If you find this video helpful, make sure to give it a thumbs up and subscribe for more Kotlin tutorials. Got any questions or ideas for future topics? Drop them in the comment section below. Thanks for watching. I'll see you in the next video. Happy coding. Thank you.